Let us next see the exercises on linear and Bernoulli equations. Let's start with the second one. We have to solve this equation x to the power 4 times dy dx plus 2x cube y equals 1. So we start the solution by noting that the given equation can be turned into an equivalent form by dividing both sides by x to the power 4. And when we do so, this is what we get. Dy dx plus 2 divided by x times y equals 1 over x to the power 4, and this equation is linear in y. The original one was not, but this one is linear in y, and the integrating factor of course is this e to the power integral of this, which in the general linear equation is p of x. In this case, p of x is 2 divided by x, integral of that with respect to x, which is 2 times ln of x. We are not putting absolute value here with the assumption that x is positive. This type of assumptions, wherever, whatever you need, you can assume those things, okay. We are not too worried about whether that is really the case or not. Right now the aim is to just get ourselves familiar with this type of equations and how to solve them. That's all. So we assume that x is positive. That is why we are putting ln of x. And then this of course becomes x squared, because first this 2 goes inside and becomes the exponent of x. And then after cancelling exponential and logarithmic functions, because they are inverses of each other, this is what you get. So x squared is your integrating factor. Now you have to multiply both sides of this linear equation by this integrating factor. So multiplying both sides of the linear equation by x squared, our integrating factor, we get this. X squared times dy dx plus, if you multiply this term by x squared and then cancel one x, you will have 2xy. And on the right hand side we have x squared divided by the 4th power of x, which is x to the power minus 2. And from theory you already know that the left hand side will be the derivative of x squared, the integrating factor, times y with respect to x. Or you can just simply see that this is really equal to this by applying the differentiation formula, the product rule for differentiation. Okay, so that's how you get this equation. And now it's simple. You know that now you can integrate both sides with respect to x. Then the left hand side will be x squared y. So let's do that. So integrating both sides with respect to x, this is what we get. X squared y equals the integral of x to the power minus 2 with respect to x plus a constant c. Now this you already know, it's your usual powered rule for integration. So you add 1 to the exponent and whatever you get, you divide by that as well, which is minus 1. So it becomes minus 1 divided by x plus c. And then if you want, you can leave the solution like this, or you can divide both sides by x squared, expressing y as this function of x. Y equals c divided by x squared. We decide to write this one first. Minus 1 divided by x cube, where c is an arbitrary constant. Do not forget to write this, okay? You mentioned that also. Although it's understood that in the context of solving a differential equation, c is an arbitrary constant, but you need to mention that fact. It shows that you know what you are doing. So this is a one parameter family of solutions of our linear equation and hence of the original equation as well. Let us next see number 6. This time, instead of x and y, we have u and v. Here v is a function of u, a differentiable function of u. So this is the equation u squared plus 1 times dv du plus 4uv equals 3u. This one also, like the previous one, is not linear in this form, but it can be turned into another equation that will be linear, which you know what to do to get to that equation. You have to divide both sides by u square plus 1. And doing that division, this is what we get. dv du plus 4u divided by u square plus 1 times v equals 3u divided by u square plus 1. I have used this parenthesis to separate the part having the variable u and v. Okay, it shows that this is a function of u and the right hand side is also a function of u. So you can now see that this is a linear equation in the unknown function v, which is supposed to be a differentiable function of u, and we now have to find that function. That won't be a single function, we will get a family of functions. That is our solution. And I am no longer going to write those sentences, okay. You can write them yourself using the previous solution. So now what is the next job? The next job is to find the integrating factor. So this is your integrating factor, e to the power the integral of p of x, except here we do not have x but we have u. This is our p of u with respect to u, and the integral is this. Integral is this means integral is this exponent 2 times ln of u square plus 1. You already know how that comes, okay, so there is no point explaining that. And then from this one, just like the previous one, this is what you get, the square of u square plus 1. So that is our integrating factor, and now we have to multiply both sides of this equation by this. So doing that multiplication, this equation gets turned into this, u square plus 1 whole square times dv du plus, here there will be a cancellation, but even after cancelling one u square plus 1, you still have another one with 4u and v. Similarly, on the right hand side, it is 3u times u square plus 1. And then this left hand side of course becomes the derivative of the integrating factor u square plus 1 whole square times your unknown function v with respect to u. And to facilitate integration, on the right hand side we do the multiplication, so that way we get 3u cube plus 3u, and then we integrate both sides, this time with respect to u, because that is the independent variable. So that's how we get the square of u square plus 1 times v equals the integral of the right hand side with respect to u plus an arbitrary constant c. So the left hand side remains as it is for now, and here if you do the integration using your usual power rule, this is what you get. 3 times, what do you get when you integrate u cube with respect to u? You get u to the power 4 divided by 4. Similarly, integrating u with respect to u, you get u square divided by 2, but 3 is already there, plus a constant. When you do this type of problems very often, you may easily mistake integration for differentiation. I mean, you are thinking of doing integration, but subconsciously you are thinking of differentiation, and when you do that, suddenly you will just write 3 here. You would think that, oh, the integral of u with respect to u is 1. No, that is the derivative, not the integral. So this is your one parameter family of solutions of the given differential equation, actually of that linear equation, but because of that the given differential equation as well. Next, let us jump and straight away see number 18. Here we have to solve the following equation, where the unknown function or the dependent variable is x and the independent variable is t. dx dt plus t plus 1 over 2t times x equals t plus 1 divided by xt. This equation is not a linear equation, and also it cannot be turned into a linear equation because already there is nothing with dx dt. So you do not have to divide by anything. The equation already is in a form where the derivative part is alone. But even then it is not linear. What is the reason? The reason is this x. The presence of the dependent variable on the right hand side and that too in the denominator. Okay, so that you cannot bring this term to that side, making it minus and take x common out, so that ultimately it turns into a linear equation. No such possibility, because here x is in the numerator and here x is in the denominator. Instead, it's a Bernoulli equation. In Bernoulli equation, the right hand side, in the original definition, where the dependent variable is y, has y to the power n on the right hand side. Here the dependent variable is x, and we do have x to the power n here, but n is neither 0 nor 1, n is minus 1. So that n in that Bernoulli equation, in the original one, is minus 1 in this case. And you know what to do to a Bernoulli equation to turn it into a linear equation. You have to use this transformation. V equals y to the power 1 minus n. In this case, the dependent variable is x. So in place of y, we would put x to the power 1 minus n. But n itself is minus 1. So that is why 1 minus minus 1 or x squared. We have to use this transformation. But because we have this, let us also see what dv dt is. dv dt by the chain rule would be 2x times dx dt. Now using this transformation and this information, we are going to turn this equation into another one, which will be having the dependent variable v and independent variable will remain t, and that will be linear. Now before we can use this transformation though, let us first turn the given equation into a form where we can easily use this. So to do that, we need an x here, so we multiply both sides by x. So this is how we write. The given equation is equivalent to the following one: x times dx dt plus this term times x squared equals, now no longer x will be there, t plus 1 divided by t, which we can also write like this. This will help us in doing the integration. And now we can use these things to further turn this equation into another one having v and t, which will be linear. So next we write like this: using v equal to x squared, the above equation means this one, 1/2 of dv dt, that we have written in place of x dx dt, which you can see from this equation, plus t plus 1 divided by 2t times v. In place of x squared, we have written v, and the right hand side of course remains as it is. Or we simplify it a little more by multiplying both sides by 2, so that we can get rid of this 1 divided by 2. So that way we get dv dt plus, and here also we do a little simplification. 2 will no longer be present here, and we will have 1 plus 1 over t, just like that side. And this side has to be times v, and this side has to be multiplied by 2. So that becomes 2 plus 2 divided by 2t. Now this is a linear equation in v, and now it's same. The procedure is usual procedure. So we write this is a linear equation in v with, do not forget to write in v, okay, in the given means the one that we now have, dependent variable v, with the following integrating factor. Here the integrating factor won't really, it will have the exponential function. You won't be able to get rid of the exponential function because of how this term is. So anyway, this is what it is: e to the power integral of 1 plus 1 over t with respect to t. Now the independent variable is t, don't forget that, don't write x. The integral of 1 with respect to t is t, and the integral of 1 over t with respect to t is ln of t, and here again we are assuming that t is positive. Those assumptions are there in the background. Okay. Now using one of the exponential laws, you can write this like this product. This part will be t, but you will have this e to the power t. But anyway, so this is your integrating factor, and now you have to multiply both sides of this equation by this integrating factor and carry out the process. That will give you a one parameter family of solutions of this linear equation. And then in that family, you have to replace v with x square. Don't forget that. And that will give you another family of equations where x will be the dependent variable. That will be your required family of solutions of the original Bernoulli equation. So I ask you to complete this process and see what you get.